Today we're going to continue on object-oriented programming, in particular on inheritance. We had gone through a very, half of a demonstration of why you would want to use inheritance, and I'm going to pick it up where we left off from last time. Remember that we are online, so if you have any questions, go ahead and post to Piazza, or go ahead and post to the YouTube chat. All right. So to remind us of what we did last time, we defined products, right? It's kind of like bananas, for example, is what we did, and then we defined subscriptions because we were trying to support this store, right? Remember the scenario here? The retail store sells products and subscription services. Products are items that have a price and a customer, so you can buy 5 bananas at 50 cents each, and that's $2.50. Or you have a subscription where it begins on a certain date, ends on a certain date, and you pay an annual fee prorated for whatever you've purchased the subscription for. And we started out by designing each one of these two classes independently. And then we started to make some observations that a product has an ID and a name, but also a subscription has an ID and a name. So in the first step, what we did is we took that commonality and put it up into a superclass. In particular, this item class right here. Okay. Let's go ahead and take a look at that now. Now it's not complete, and we're going to continue working on this, but I just wanted to remind you what it looks like. It's an item. It has an ID and a name, right? And then over here in the product class, what we did is we extended the item. We extended its behavior so that it would inherit all these things. And that allowed us to get rid of the ID and the name, right? And now that's where we'll pick it up here. So the problem here is that the product ID no longer exists, all right? The name exists, but now that I put it into the superclass up here, there's an ID and a name. So, okay, well, all I need to do is rename this from product ID to simply name. But I can't access those. Let's go ahead and find out why. The item.name is not visible. So let's go ahead and follow that and go back up to the superclass and find out why it's not visible. Why is it not visible? It's private. When something is private, only that class can see it. So what I've got right now is an item up here and a product down here. This is the class that I'm in right here, the superclass. It can see ID and name, but down below in product, it can't see those things. Right? Because it's private to that class. It's inheriting those things, certainly, but it can't see them. That's okay, because we have a getter to get them. Get ID. There we go. And product p.getName. And what I'm doing here is I'm passing these off to this other constructor over here. Given this product p, I get its ID and its name, and then I pass it off to this constructor that sets all those things. What does it do with the product ID, though, now? In fact, I'll go ahead and rename this to ID and ID and update this one up here. Right? So what is it doing? It's calling the super constructor. Why? Because the ID and the name are defined in the superclass. And so what it's doing is it's taking those two things and handing it off to the constructor above. It's constructing that part of the item class, and then I set the price and the quantity down here because that is specific to the subclass down here. Remember, the reason that we want to use inheritance is because it allows common functionality and state and behavior to be located up here in the superclass, while there's specific behavior, specialization provided down in the subclass. Sometimes we call these child classes too. Right? Now, let's go ahead and continue with subscription over here. Now, we're not done with item. Right? We'll come back to that. But let's go ahead and redesign the subscription here, because it is also an item, right? Product is an item, a subscription is an item. We have this common functionality here. So I'm going to go ahead and get rid of the subscription ID and the name entirely here. And I'm going to, what was the keyword we used to extend the behavior of a class? Extends, right? It extends the item class, okay? I only have to provide the specialization here. The common features, the common state and behavior, they get thrown up into the superclass. Now let's see how that affects everything around here. Well, now instead of a subscription ID, I have an ID and a name, but I call these super constructors, the super classes constructor, passing those off. I don't set those directly anymore at all. Right? I let this superclass handle that so that I don't have repeated code. Okay? Otherwise, everything else is perfectly fine. All right? Now, let's remind ourselves what product costs here. So again, if it is a banana, well, let's go over to the demo here. If it's a banana and I buy 8 of them at 25 cents a pop, that's going to be $2. If I buy a dozen bananas at 25 cents a pop, that's going to be $3. Where is that computed? Over here in the product class. Here's the cost. This price times this quantity. Simple enough. But is that the same behavior as a subscription? Nope. A subscription, what we have to do is we have to get the days between the start date and the end date, divide by 365, ignoring leap years, don't worry about it, and then multiplying it by the annual fee, and then of course I'm going to round that to the nearest cent, right? And then I return that cost right there. So specific behavior down here in the subclass, subscription, different specific behavior down here in the other subclass for product. Now let's go back up to the item class here. Right? So what is the cost of an item? Or, a generic item? Right? Is it well defined? No. So one thing I could do is I could return, some flag value, -1, right? -1.0 or something like that. I don't know how to compute this because all I am is a generic item. I don't know if I'm a product or a subscription. So all I can return is some flag value, or maybe it's 0, right, as another flag value. Right? Likewise, instead of getting product ID, I'll go ahead and go. The other fix here is just ID. Again, I guess I get rid of this entirely here. There we go. There's ID and there's name. Right? All right. So does that sound like a good idea, though? Right? So is there such thing as an item? Right? I could create an item over here in the demo. Let's go ahead and try that. Item something, right? Something, I don't know what it is equal to new item. And I can provide it an ID, foo123, and the name, I don't know. What is it? What do you call this thing? Over here, we called these bananas. Why? They were called bananas. Over here, this is an Xbox Live subscription. Why? It's an Xbox Live subscription. Is there such thing as a generic item? What would you label it as? Right? I have no idea. Right? So should we even be allowed to do something like this? Doesn't sound like it would be a good design. We can prevent that design by making this what's called an abstract class. Public abstract class. Right? It's an abstraction. It's the idea of an item. It's the idea of a banana. The idea of an Xbox Live subscription. Right? It's as generic as you can get. And if it's so generic that you can't do things like, get the cost, then it's probably telling you that you need to make that abstract. Over here in the demo class now, because I made this abstract, guess what? I can't create it anymore. Right? An abstract idea, right? You can't create it, right? And so this is preventing you from doing it by making it into an abstraction. What's the antonym? What's the opposite of abstract? Concrete, right? A product is a concrete idea, right? A banana is an actual thing. A subscription is a concrete idea. We know how to compute the cost of those things because, for example, subscription has a defined annual rate, a start date, and an end date. A product has a well-defined price and quantity. So therefore, we know how to get the cost. Over here in demo, since we don't know how to compute this, well, we can prevent it by making it abstract. Now, that means that I can now redefine this getCost method to also be abstract. Right? And an abstract method is one that I don't know how to implement that. Instead of returning a flag value like -1 or 0, right? I'm just going to say, well, there is the idea of a cost to this item, right? If it's a product, you compute this cost one way. If it is a subscription, you compute this cost a different way. But up here in the generic item class, this abstract idea, I don't know how to do it, so I'm not going to, right? Now down here in the subscription, since it's not an abstract class, If I don't specify how to compute the cost, then that's going to be a problem, right? This is a non-abstract class with an abstract method, right? You can't do that. It has to be concrete, right? That antonym there. It has to be concrete. The type subscription must implement the inherited abstract method getCost. I'll restore that, and the compiler error goes away. Right? So all of my problems have been solved now by creating an abstract class. If you don't know how to do something, then don't do it, right? Just say, well, there's the idea of getting a cost. There's the idea of, computing the value of something or something like that. But I don't know how to do it, so I'm going to let the subclasses do it, because that's where you provide specific behavior, down in the subclasses. Okay? This looks pretty good. Let's review everything that we've looked at so far. Okay? So, again, inheritance allows you to reuse a class by extending its behavior. Common functionality in state and behavior is placed into the superclass. And by the way, we have both, right? We have state, we have ID and name, and getters, of course. We also have behavior, getCost. The generalized behavior would belong up here, but there is no generalized behavior because I don't know how to compute the cost of item, right? Thing, right? Object, right? You have to have a concrete definition of what you're talking about in order to compute the cost. That's where specialization or specific behavior comes in. Behavior is overridden in the subclass, and often you'll see something like this, override. Right? In fact, if you automatically generated this code, Eclipse would put this annotation in there automatically. You don't have to have it in there, but it is a nice idea, because if you put it there and this is not an overridden function, like, I don't know, public double foo, right? I am not overriding anything from above, so return 0, just to get it to compile here. Right? It's complaining because your claim that this was an overridden function, that you inherited the method from the superclass, and then you're redefining what it does to return 0. But that's not, in fact, the case, because there is no foo method up here in the superclass. And so this annotation here is telling you that there's an error. This is fishy. The method foo of type subscription must override or implement a supertype method. Right? You're not overriding anything because it's not in the superclass. So it ends up being a compiler error or compiler warning here. Right? So use the override annotation, or don't. Just be consistent about it. Okay? All right. So generalization, specialization. We also call these, as I hinted at before, that if a class A extends a class B, right? I'll use those. So A would be the subclass. So A is the subclass, and B is the superclass. Another way of putting this is that A is the child class, and B is the parent class. Other words to use to describe these would be the inherited class, the derived class, something like that. You come up with a half a dozen different ways of putting this. It's a hierarchy. Right? Here's another hierarchy that you're probably familiar with, at least in usage. Right? Anytime that we created an array list, guess what? There was this whole hierarchy going on. An array list, we treated it like a list. A list is also a collection. Right? This very simple hierarchy is built into the Java collections library. And look at the pattern there. General generic behavior up here. What is a collection? A collection is a bag of stuff, right? Is it ordered? Is it unordered? I don't know, right? That's more specific behavior. What's the difference between a set and a list? What is a set? It's unordered. A list is ordered. So in other words, we have this specialized behavior, ordering and unordering. Then you have even more specific behavior. A set is a collection that holds stuff in an unordered manner. A list is a collection that holds stuff in an ordered manner. Down here, we used hash sets and array lists. We haven't talked about linked lists or tree sets yet, but We will eventually. So tell me about this, a hash set. A hash set is a set that holds stuff, which is a collection that holds stuff in an unordered manner that uses a hash table to represent its data. Over here, a tree-based data structure is used, right? So there's different specialized behavior as you go down in the hierarchy. A list is a collection that holds stuff in an ordered manner, right? And an array list is a list that holds stuff in an ordered manner using an array under the hood. Over here, a linked list is something that holds it in an order, but using a linked list. So we've got this node, and it points to the next node, and that points to the next node, and it points to the next node. It's a chain of nodes going back and forth. We'll talk about that in more detail when we actually get to data structures and algorithms. You can get a lot more complicated, in fact. In fact, here's the full inheritance hierarchy up here. Right? Tree set, hash set, array list, and a linked list. If you look at all the classes in between this entire hierarchy, you get abstract classes and then interfaces. Interfaces we'll talk about here in a moment, but those are purely abstract classes. There are no concrete methods at all, no non-abstract methods. Why do we do something like this? Why do we have this hierarchy? Where else do we do hierarchies? Think about your biology. King Philip. Does anybody know that mnemonic device? King Philip. Oh no, what is it? Nobody remembers their biology. King Philip. Biology. It's a text. What is it again? Came over for good spaghetti. Is that it? King Philip came over for good spaghetti. What is that referring to? Kingdom, phylum, genus, category, whatever it is, right? Genus, then all the way down to species, right? What is that doing? What is that hierarchy doing? It's organizing biological things, right? What is this hierarchy doing? It's organizing code, right? We do this all the time. Think about hierarchies. Directory structures are hierarchies. You start out with a root idea, and then you get to more and more specific ideas as you go along, right? You start out with a general living things, and then you split them into plants and animals. The animals you split up into reptiles and mammals. The mammals you split up into whatever. We like to organize stuff, and a hierarchy is a natural way of organizing stuff. Why? Because it allows you to focus only on one thing at a time, right? It also sets up a diagram. Everything in this box that I just drew is an abstract collection. In other words, inheritance defines an is-a relationship. Let's go back to the simple one here. A hash set is a set. A set is a collection. Right? And so it sets up this is-a relationship. Right? Inheritance defines an is-a relationship. So let's take another look here at another more obvious answer, right? Something that doesn't have anything to do with the code that we've written so far at all. So I've created an ostrich class here. I've created a robin class, right? And a bird class, right? And I've followed the same pattern as before. Think about a generic bird, right? Some birds fly, some birds walk, some birds swim. How does a bird move? Can you answer that without knowing more about what the bird is? No. All right? It depends on the bird. It depends on the type. It depends on the specific type of bird. What about speaking? Birds do speak. Some of them tweet. Some of them squawk, right? Whatever they're going to do. Whatever a bird's going to do. And so what I've done is I've defined an ostrich. All right? Well, before you take a look at that, how does an ostrich move? Can ostriches fly, by the way? Nope. They what? Run or walk if they're not in a hurry, right? What do they do for speaking? It's not a pleasant noise, right? And so I characterize it just as a honk, right? What about a robin? Does a robin have the same behavior? The same specific specialized behavior? No. A robin flies because that's a bird that can fly. And it also tweets, right? I don't know if that's what you call it, sings, whatever, right? So the idea here is I've created this hierarchy, right? Is everything, is a robin a bird? Yes, right? That's why I've defined it as a subclass. Is a bird necessarily a robin? No, right? What about an ostrich? Is an ostrich a bird? Yes. But is a bird necessarily an ostrich? Right? Nope. So now let's take a look at comparing ostriches and robins. Let me move it over here. Is an ostrich a robin? No, definitely not, right? Sometimes a bird can be a robin. It depends on how you created it, right? And so that sets us up another diagram that I've got here. Let's see. There we go. So here is that same inheritance hierarchy, but with respect to birds, robins, and ostriches. When I look at one perspective versus another perspective, I get three different types of variance. Right? So again, is a robin a bird? Right, let's look at this line right here. Is a robin a bird? Yes. That is always true within the hierarchy, and that we call that a covariant type. Right? A bird is, or a robin is a bird. Likewise, an ostrich, when I look at an ostrich with respect to bird, that would also be covariant. But what if I look at the opposite direction? What if I look at a bird and I ask, is it necessarily an ostrich? No. It could be, right? Because some birds are ostriches, but not all birds, right? That's called a contravariant type, right? So the difference here is this is always safe. This is sometimes safe. Right? What about down here? Can I convert a robin into an ostrich and an ostrich into a robin? No. And so we call that an invariant type. You can't convert between those two types. You can think of other ideas here. For example, an integer versus a double. Are those the same thing? No. But what's the commonality between them? They're both numbers, right? And you can define a hierarchy, a number, right? And then this one is a more specific type of number, an integer. This one's a more specific type of number, a double. You can have yet another more specific type, a float, right? Or short, a long, etc. Right? Those would all be. You could put that all into a hierarchy. In fact, I think they are. Let's check it out. Let's go ahead and create an integer here, integer x, and let's open up that class. Hey, it extends what? A number. What does number extend? So we went from the specific type, integer, up to a more general type, number. What is a number? Think more generally. A what? Oh, okay. It implements serializable, but that's it. That's there we go. Let's go to its superclass here. It's not the end of the line yet. What do you think when I jump up one more level here above a number? What do I get? A what? A headache? Let's find out. Java is an object-oriented programming language. What does that mean? Everything in Java is an object or belongs to an object. And this is the end of the line, right? You can go from as most specific as you want. You can go from this big giant hierarchy here, from a linked list all the way up, and I didn't depict it here, but you could go all the way up until the end of the line where everything is an object. What is an object? An object is just a generic thing. Do you see any state here? Nope. But I see plenty of behavior, right? Plenty of, don't worry about that. Do I have any non-native? Okay. An equals method. Where's the toString method? Come on, where are you? Oh, previous. There we go. Hey, what is that? It gets the name of the class with an @ sign and then the hash code to hex, right? Look familiar? When you don't override the toString method, when you don't implement the toString method, what do you get? You get the class name, an @ followed by this gobbledygook hexadecimal number, right? And that is the hash code. There's its implementation right there. Okay? That's the end of the line, though. Everything in Java is a class or an object or belongs to an object, or a class versus a class object interchangeable there, right? At least with respect to Java. All right. So let's take a look at an actual demo here, right? Is it possible to create a generic bird? Does it fly? What happens when it moves? What happens when it speaks? I have no idea. So it's not even possible to create an abstract class. I then create an ostrich. I then create another ostrich, but I refer to it as a bird. Is that okay? Yeah, why? Because it's covariant, right? An ostrich is a bird, okay? I create another bird, B2, and make it and treat it as a robin. Is that okay? Same reason. It's covariant, right? So when I do move and speak, right? What's going to happen here with O? O is an ostrich, so how does an ostrich move and speak? It walks and it honks, right? Let me change this to B2 or B1. Now that's just a bird. A bird moves, a bird speaks, because all birds move and all birds speak, right? But how does this bird move and how does this bird speak? Predict what's going to print here again. Well, B1 is what type? It's an ostrich. So an ostrich is walking honk. Let me change this again to B2. Okay? Now once again, predict what's going to happen here. How is this bird going to move and how is this bird going to speak? It's a robin, so it's going to fly and tweet. All right? Let me do one more. Let me create bird B3, and I'll set it equal to O. Right? I'm not even creating a new one here at all. Right? What's B3 going to be now? It's an ostrich. Why? Because it's making a reference to O, and when O was created, it was an ostrich. What about B1? What is B1 again? When it was created, it was an ostrich. I can change that, right? I can say that B3, let me go ahead and change this to just B2. B2 is equal to new ostrich. And, oops, there we go. And now what happens when I print out B2? Is it an, oh, well, I got to spell it right. There we go. All right, now what's going to happen? Walking honk. Why? Because it's an ostrich. This is just a reference type, right? It's referencing, a bird can be an ostrich, it can be a robin, it can be an ortolan, it can be whatever do you design it to be, right? But when you actually invoke these methods, what happens is it goes to the actual instance and asks, well, what do you actually do? Do you walk or do you fly? Do you tweet or do you honk, right? The way that that works is through what's called a virtual table. Right? So when I create an ostrich, a brand new table of how, in this case, I've got move and walk instead of move and talk, but that's okay. When I create a robin, then it creates its own table. The move method is a reference to this fly code over here. And this move method is now a reference to this walk method over here. Right? These are called V-tables or virtual tables. When they're created, when you call that new keyword, or use that new keyword to create these things, then these references are created and they're fixed until that object is destroyed. You can't make this move method point somewhere else. You can make the reference point to a new bird if you want, or a different bird, but you can't change this table once it's been created. Right? It remembers which code am I actually referring to. Is my move method printing out walking, or is my move method printing out flying? Right? And that's how inheritance actually works. That you've got this code, and only at instantiation, only when you create these objects, does this virtual table get created with references to the correct method. Because I see a lot of methods named move here. I see this actual method, I see the method in the ostrich class, and I see this method over here in the abstract class. Now, again, why would you want to do this? 1, organization. 2, code reuse. Right? 3, polymorphism. That's not, so this is a preview of what we're going to focus on next time. But what I'm going to do is I'm going to create a flock, right? So I don't know, a set of bird, right? Actually, no, a set of ostrich is ostrich. So I've got my ostriches, O's equals new hash set. And then I've got my set of robins, R's equals new hash set. And I want everybody to migrate. So import this, import this. So I've got a set of ostriches. I can take, and I can add O, s dot add O. Why? Because it's referred to as an ostrich. But can I take and add B1, right? os dot add B1. Let me go ahead and get rid of this for now. I'll just keep it simple with 3 birds here. Can I add a bird, generic bird, to a set of ostriches? No, why not? That's what? Contravariant. Can I force a bird to become an ostrich? Yes, I could, technically, right? I could do something like this. I could say ostrich. Is that how you spell it? I'm not sure. Ostrich O2 is equal to B1, right? There we go. So am I able to do that directly? Can I take B1, which is an ostrich, but it's referred to as a bird, and can I force it to become an ostrich again? Not directly like this, or indirectly like this, if you want to look at it that way. But what could I do? When I do integer division divided by an integer, it's not going to work. Why? Because of truncation. What can I do to force an integer to become a double? Typecasting, ostrich. I can force that bird to become an ostrich, right? Is that safe in this case? In this one very particular case, yes. Why? Because B1, sorry, is an ostrich, right? That'll be safe. And now I can go ahead and add O2 because it is an ostrich. No problems here whatsoever, right? And here, I'll migrate. System.out.println migrating ... I don't know if I don't think either one of these migrates, but whatever. For bird B in the collection of ostriches, or B dot move. There we go. And I'll do the same thing for robins, RS. There. So migrating, and then they all get moved. Right? Everything's fine. What happens when I try to do the same thing? I force ostrich O3. I force B2 to become an ostrich. Is that going to work? B2 is what? A robin. Can I force it to become an ostrich? No. Again, sometimes that's safe. Sometimes it's not. Here's a case when it's not safe. What's going to happen here? Robin cannot be cast to an ostrich because they're unnamed module, blah, blah, blah. It is a class cast exception. Right? What kind of what kind of variance or what kind of coercion or typing am I doing now? The invariant, right? I tried to force a robin to become an ostrich, and that's not going to apply. Right? Right? All right, so I can't do that. Right? I can't. You cannot do the following. Okay. All right. So therefore, I can't add it to my set of ostriches, even though everybody moves. Right? I want one set to take care of all of these things. If I don't have one set, then I have to do all the ostriches separately. I have to do all the robins separately, even though they're all birds. Right? All birds move somehow. So what I could do is I could create a set of birds. Flock equals new hash set. And I'll move the flock entirely. Bird in flock. There we go. Okay. Now what can I add to flock? Can I add, yeah, it's an ostrich. An ostrich is a bird, right? This is an is a relationship. Flock dot add O2. still a bird, flock.add r, what did I call it? B2? There we go, B2. I can add ostriches, I can add birds, or I could add, if I create a new bird in the future, an ortolan, or give me another bird, an emu, right? I can go ahead and add them to the flock, right? Do I have to change this code at all? No, code reuse, right? And this gets into, again, polymorphism. One piece of code that can be applied to multiple types. And there, some migrating, walking. Oh, were they all walking? Because why did I? B2 is a robin. Oh, I never added B2. There we go. Oh, I can add both. There we go. There. Now I got him. There, now he's flying. Okay. So again, why would you want to do this? Organization, code reuse, simplification of code. If everybody has the common interface, for example, if all collections hold stuff, then all of that can be hoisted up to the superclass here, and I can treat sets like a collection to sort them, not to sort them, but to do stuff with them. I can take a list and treat it like a collection to do stuff with them. But once I need that specialization, then I need to go down in the hierarchy, right? And now I have a less common interface, but for example, an array list and a linked list can both be treated like lists, and you don't have to worry about the actual implementation details. Abstraction working along with inheritance, all right? Okay, so let's go back over to the notes here. Okay, let's see. I'll go ahead and just bring this over. A subclass is a relationship to its superclass. A robin is a bird. A bird is not necessarily an ostrich. A robin is a bird that's covariance, right? Or covariant. This is contravariance. And what's the third that's never safe? Invariant coercion, invariance, which would be invariance, which would be you cannot make a robin into an ostrich. Okay. One thing you can use is instanceOf, but should probably not, unless absolutely necessary. Right? So suppose that we've got this generic bird, right? In fact, I'll just move all the way down here and forget all about that stuff up there. And let me just go ahead and create a bird B, right, is equal to, I don't know. Is there anything that I can do with B? Did I already use B? No, I'm fine. I'm fine. All right, I really need it to become an ostrich, right? What I did up above is I made a class cast, right, O2. Right? Do I keep misspelling this? Ostrich. There we go. All right. So again, is that safe or not? Or maybe? Maybe, right? So let's go ahead and put that maybe into a more safe piece of code. If O2 is an instance of ostrich, then you can do something like this. Right? Otherwise, else you cannot, or printf, you cannot force O2 to be a bird. Sorry, ostrich. Oh. Can I do O3? Have I taken that one already? O2 to be a ostrich. There we go. That's what I meant. Sorry. All right. Let's find out. Is O2 an ostrich? I forget because I scrolled all the way down here. Is it safe or not? No, it's not safe. Why? If I backtrack, what is an O2? An O2 was forced to become an ostrich. It's B1, right? B1 is an ostrich. Oh, you know what? Oh. O2, oh, not OS. O2. There we go. Sorry. All right, there. Yes, you can force it to become an ostrich, right? It works. Yes, O2 is an ostrich. Now let's go to something else that we know is not an ostrich. A robin. Do I have an R up there? B2. Right. And I'll force B2 to become an ostrich. Is this going to be safe? Nope, because it's a robin. And so instead of doing this unsafe code here, it goes down here to you cannot do that. Right? So you can use this instance of keyword to check whether or not something is an instance. By the way, regardless, is it going to robin, or you can use robin, you could use bird, right? You could use object. Guess what? That's always going to be true. Why? Everything is an object, right? Except for the primitive types. Small I, int, small d, double, etc. Right? All right, go all the way back over here to ostrich. Right? Almost never do you actually want to do this. There's only one specific instance which you'll want to do this on your project. Otherwise, you will want to rely on the interface. How does this bird move? I don't know. That's for the subclasses to decide. That behavior belongs in the subclasses. You shouldn't have to, for example, with product and subscription. If I were to use the instance of keyword to determine how the cost is computed, I would be breaking the inheritance hierarchy entirely. Right? Don't do that. Instead, it belongs in the class. That breaks encapsulation, it breaks inheritance, it breaks a whole bunch of stuff. If I did something like this over here in my demo, if let me just go ahead and create something generic here, item, right? And it's uninitialized, right? But if item instance of, what is it, product, right? To do, it's quantity times price, right? And then else if item is instance of subscription, then to do compute the number of days times the annual rate, right? Dot, 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 right? Now this is obviously not going to compile because this is uninitialized. I can go ahead and set it equal to null to at least get it to compile. But is this the right way of doing it? Think ahead. I'm going to have a lot more products, types of products in this store, right? I could add in, I don't know, what else does Source sell? Liquid, or I don't know, a gift card or something like that, right? If I added a new one, what would I have to do every single time? Add another else if, else if, else if, else if. If you had 10 different types of products, what is that going to look like? A big giant else if, else if, else if, else if. Right? And if you're doing that all over the place, you are not centralizing your code into where it belongs. This looks like a product thing to me. Where do product things belong? In the product class. This looks like a subscription thing to me. Where do subscription things belong? In the subscription class. By having this series of if, else if, else if, else if, I've completely blown away all encapsulation. I've ripped open my classes. I might as well not even define classes at this point at all, right? If I'm going to do something like this. The only time that you'd ever want to use instance of is if you need to call a constructor, right? If I want a copy of something, right? Because, for example, let's see, I want a copy of product. So product P is equal to new product, which is a copy of the other product item, along with its, I don't know, instead I'll get 24 bananas instead, right? And are you going to complain about that? Yeah, you're going to complain about that because it has actually taken a, what is item? Oh, let me look at the constructor. It requires a what? A product, not a generic item. So what do I need to do? I need to force it to become a product. And only then is calling the constructor safe. And that was only safe because I checked to see if it was an instance of it. But if you're doing something like this, bad. Right? Don't do that. But if you need to call a constructor, that's the one and only time where it's absolutely necessary to check that it's an instance of whatever you're trying to copy. Because what if I tried to copy an item and it was a product, but I tried to copy it as a subscription. Again, what type is that? An invariant type. Right? You can't force a product to become a subscription or vice versa, just like you can't force a robin to become an ostrich. Right? Okay. So, generally, you only do this, use this with constructors, right? And in particular, copy constructors. Right. All right, great. Again, the motivation for using inheritance is that it provides a way to reuse code, right? Avoid repeating code, right? By placing it in the superclass. Right? And it provides a way to organize code. We like hierarchies. We like putting things into nice little neat boxes that are related to each other, etc., because it allows us to not have to think about every single organism on this entire planet at once, right? If I just laid out all the organisms in a big giant list, right, then that's too daunting of a task. But if I start organizing them and I only talk about mammals, or I only talk about reptiles, right? Now I have some common characteristics. All reptiles have this characteristic. All mammals have this characteristic. And then you can get down even, even more specific. All hominids have this characteristic, et cetera, et cetera. Right? All right. It provides a way to organize code. Right? Abstract classes. If you have a class that is not well defined, make it abstract. Abstract. Right. Abstract classes may have state and methods. Right? Optionally, abstract classes may have abstract methods. Methods that do not have a body. Right? In fact, anybody coming from a C background, what does that look like up here in item? That abstraction, that abstract declaration right there. What do we have in C that we don't have in Java? Prototypes. Right? Well, what is a prototype? A prototype is just a description of the signature. There's this function called getCost. It returns a double, and it's public. What does it do? I don't know. Don't ask me. I'm abstract. Right? I don't actually exist. Only when you go to a non-abstract class and you define it, does it then have a body, and then you can ask those questions. Right? Okay. So abstract methods that do not have a body, but force subclasses to specify behavior. With abstract classes, you can prevent someone from creating instances of them. Right? Okay. With inheritance, there's another keyword that you can use. Sometimes you want to prevent subclassing. Right. To do this, you can make your class final. So we've seen the keyword final before, right? In what context? Say again? If I make a variable final, what happens to that variable? It ain't a variable anymore. What is it? What's the opposite of variable? Something that can vary, something that is constant, right? For example, in the math class, math.py. Right? Let's go ahead and take a look and see what that looks like. Guess what? It is final, right? You cannot change it. Right? Well, when you apply it to a class, it's the same thing. For example, it's a similar thing, I should say. Let me go over here to item and say that it is a final class. It's not going to let me do this if it's abstract, so I'll go ahead and get rid of this and get rid of this for a second here. There we go. You're fine. Item is fine. But now let's take a look at product over here. It extends an item, but item is made final. Am I able to do this anymore? The type product cannot subclass the final class item. Now, let me undo that because that's not the design I wanted. Right. And let me show you an actual use case for this. An integer, x. So would you ever want to subclass an integer? Is there a more specific type of integer? What if I did the following? I made it so that the integer was subclassed, but now addition becomes subtraction, and subtraction becomes addition. Or I modify its behavior so that every time you access it or its value, it increments by 1, right? Something completely weird and unexpected. Would you want to allow anybody to do that? Probably not. And so, consequently, that class has been made final. I cannot create a class that extends integer to change its behavior, and that's a very good thing, right? The integer has well-defined behavior. Everybody knows what an integer is. Everybody has an expectation of how an integer behaves, right? If I go changing the program, I am changing everything about how all this code works, right? And to prevent that, we've made it so that you can't by making it final. The Java folks have. Ever since, by the way, version 1. Good job, Lee, Arthur, Josh, and Joseph. Right. So that's another reason that you want to put in documentation, because your names will live on forever if it's in something that everybody uses. Right? Okay, so that's another aspect. You can make a class final. You can also make a method final. It prevents any subclass from overriding that method. So instead of making it so that you can't inherit that class at all, you can be more precise. Yes, you can go ahead and subclass, say, an integer, but you can't change what addition means, right? If you want to be a little bit more specific. By making the addition method final, you're not able to change it in the subclass. That's another. So there are 3 key uses of the keyword final. All of them are very similar. You can't change a variable's value. You can't change a class's behavior. You can't change a class itself in those 3 different contexts. Right? Another word for this is using by default in Java. All methods are virtual. They can be overridden in the subclass. Right? 2 Ds in a ridden? Yeah, there we go. Right? Otherwise, by placing final in front, they are no longer virtual. I don't know. I don't think that there's any antonym to virtual. It's just they are non-virtual. Now, this is exactly the opposite in some other object-oriented programming languages. For example, in C++, it's just the opposite. By default, everything is a non-virtual function, and to make it virtual, instead of using the final keyword, you use a different keyword. Guess what it is? Virtual, right? You can make it so that you can subclass it. And they just chose to swap the defaults. Can you do it? Can you not do it? Another aspect is interfaces. A pure abstract class is one in which no functions are defined. In other words, i.e., all functions are abstract. Right? And in Java, in Java, you would use what's called an interface. An interface is a pure abstract class. You don't even define. You can put as many function signatures in there as you want. Generally, you want to keep it small, though. But you don't define any bodies at all, right? This allows you in Java to implement an interface, and more so, In Java, you can only extends one class, right? This is called a single inheritance hierarchy, right? But you can implement, or implements, all right? I should have said implements, there we go, multiple interfaces, all right? Now, to understand that idea, let's go back to that larger diagram here of all of these collections, right? I've got abstract classes here, and I've got classes here. If I ignore everything above this line right here, everything below is a class. An abstract set extends an abstract collection. A tree set extends an abstract set. You can only do one. You can't inherit multiple things, right? But if you go up to pure abstractions, interfaces, you can. Look at serializable. Serializable just simply means that you can write it out to a file or write it out to disk or something like that, right? Which is what you're doing right now, EDI, right? You're manually making everything serializable into XML and or JSON format. A serializable Java class is simply just something that says, you can take this class, you can dump it to the pure bytes, and another Java virtual machine will be able to understand it, right? And here's how it's done, right? And that's what serializable means. Guess what? You can apply serializable to different classes. You can also apply clonable to different classes, right? So that, for example, let's take a look at linked list down here. It inherits from one class because of this single inheritance hierarchy, but it can implement 1, 2, 3, 4 different interfaces. Right? So it doesn't lock you into this hierarchy. Down here, this hierarchy, that's locked. You can't change that. Right? Once you've defined your hierarchy, it is extremely difficult to change later on. Because if you take things and start mucking with them, you are mucking with the is-a relationship. If I take an abstract list and move it, right, all the pieces below it fall. Right? Everything below it breaks. But if I keep things flexible and in the pure abstract sense up here, and only implement interfaces, then it's a little bit, then I don't break something if I change something around. Right? I'm not locked into that hierarchy at all. Okay? And that's the main difference. It's a pure abstraction versus a half abstraction versus no abstraction whatsoever. Right? So it's a hierarchy of abstraction as well. Right? They're just ideas up here. These are some ideas and some concrete implementations. These down here are pure, all concrete classes. Right? All right. So that's an interface. Do I have another example? Here's another example of inherit. Nope, not that one. Not that one. There we go. Here's another kind of artificial example, but you're going to see it tomorrow in your. Then this is not the exact same thing, but you're going to see it tomorrow in your lab. I want to support a payroll system, for example. And I've got 3 different types of employees. Some of them are payable, some of them are not payable, and some of them are salaried, some of them are hourly, et cetera, et cetera. So I've got an employee here, but then I've got 2 types of employees. One of them is paid hourly. So they work 48 hours a week times hourly rate, hopefully it's $20 an hour or something like that, and that's how much they get paid. Right? A salaried employee doesn't matter how many hours they work a week. They get paid a fixed salary each week or whatever pay period. Right? But then I also have interns over here. Interns are people. They're not always treated like people, but they are people, right? So what if I put that into a hierarchy, though, right? Then I couldn't have like say a supplier, right? A supplier is somebody that I pay, not a salary, but I still pay them something because I need something from them. But are they a person? No, not necessarily. It could be a company, right? It could be a person off the street. Oh, yeah, bring me some lead pipes or something, I guess, right? But a supplier is generally another entity, a business-to-business kind of a transaction, right? So a supplier is somebody who I pay, but I also pay my employees. But I also have these interns over here, which are kind of employees, but that means that I would end up having to pay them, right? And I don't want to do that, right? they just get exposure or experience or something like that, right? No, so by putting them into interfaces up here, this is a person, this is not a person because it's not implementing this interface. Then I can also make it so that it's payable, right? And I'm not locking these into a hierarchy. Some things are another thing, some things are a different thing, but if I put it all into one big hierarchy, I'm forcing a supplier, say, to become a person, or I'm forcing an intern to become payable, right? Never taken an unpaid internship in this discipline, by the way. I don't know, quick poll. Go ahead and if you're not comfortable doing it, fine. But go ahead and anybody with an internship, shout out your hourly rate if you're comfortable with sharing it. No, no. All right. Well, I'll just say LAs get paid, I think, 10 or 12 an hour, maybe up to 14 an hour now, and that's low. That's on the low end. There are companies that will be visiting next week or this week, by the way. And you should be getting your butts over to the career fair to meet them. There are companies in this right here that pay $20, $30 an hour for internships, right? That's good. In fact, you should probably consider that average at this point, right? $20, $30 an hour, right? $20 to $30 an hour, right? Somewhere in there, right? And if it's anything lower than that, tell them to go pound, right? All right. So never ever accept an unpaid internship in this discipline here, right? Unless you're working for, I don't know, your parents or something. I don't know. All right. So questions on interfaces? No? Okay. So let's talk about a little bit about pitfalls, and we'll probably have to continue it next time. All right. So again, some languages support multiple inheritance. Right? Multiple inheritance is where you can inherit or extend. Oh, sorry. Let's go ahead and yell at me if I do that again. Extend from multiple classes, not interfaces. Right? Java is not one of them. C++ does allow this. Right? The problem is you get into the diamond problem. Right? So consider the following. I have a cat and a dog. Right? What's the commonality between them? They're animals, are both animals. Right? Now let's suppose that I inherit from both a cat and a dog. Now create a class, question mark, that inherits from both a cat and a dog. And I'll say that those are classes. Now let's go back to the question mark. What is it? A monstrosity. Abomination. Right? Or usually it's cat dog, but maybe you're all too young now to remember that. It was a cartoon, right? It was a cat dog. What did it look like? Cat on one end, a dog on the other end, right? It was an abomination, a monstrosity. It was just a cartoon, though, right? So when I call the speak method on cat and dog, a dog barks, a cat meows. What does this one do? Both, right? Does it inherit from the cat or does it inherit from the dog when it speaks, right? That's the diamond problem. Why? I've got a cat and a dog. They're both animals, right? Now draw in the air here, right? Animal, cat, dog. And if I create this cat dog below it, what do I have? A diamond, right? And that's why we call this the diamond problem. It's an ambiguity, right? The inheritance is ambiguous, right? And not well defined. Well defined, right? Java avoids this, for the most part, avoids this by forcing a single inheritance hierarchy. You can only extend one class. Right? So avoid this entirely. Even if you're in a language that allows this, really think what you're doing. Now C++ resolves this by saying that, all right, well, if you're going to do this, you have to tell me, are you inheriting your talk method from the dog or the cat? Right? You have to explicitly write code to do that. But it's kind of a design smell. We've talked about code smells before. What are code smells? Do you remember that? So something smells, right? What do? You try to isolate that smell. Why? Because it kind of stinks, right? That means there's something wrong, right? There's potentially something wrong. Oh no, that's lutefisk. That's just fine. You can go ahead and eat that, right? Anybody have lutefisk before? It reeks terrible. It's fish that has been cooked in lye. It reeks really bad, but it's a delicacy, right? It's a upper Midwest delicacy. All right, but so smells are not necessarily something that is bad, but it indicates that something is probably wrong with your design. And you've got a code smell here. We call these, in the context of object-oriented programming and other things, we call these anti-patterns. Do you remember that? Right? Anti-pattern is something that is a bad habit to get into. Another anti-pattern is the God, well, we've already talked about the God class. Another anti-pattern is the yo-yo problem. Right? So inheritance hierarchies should generally be shallow. Right? Deep hierarchies mean you are always looking up and down the chain to identify state and behavior. Right? So imagine a really long chain of inheritance, right? 10 levels deep. Okay, I need to determine, all right, well, what's the common interface for this thing that I'm working with here? I go up, 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 up. Okay, there it is. Now I need something a little bit more specific for a different use case. Down, 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 down. Okay, that any more specific, and I can't deal with it, right? What are you doing with your head? If it's really deep hierarchy, you're looking at the documentation, going up and down, as if it were a yo-yo, right? So keep them shallow, right? Not necessarily like fully shallow, right? This is shallow enough, right? There's 1, 2, 3 levels deep. I think that there's a couple, well, here, 1, 2, 3, 4 levels deep. 5, 6, 7, 8, 10, dozen, 2 dozen. That's probably a code smell right there. That's probably an anti-pattern you want to be careful of. Right? Another pitfall or anti-pattern is going to be the rectangle problem. And to illustrate that, I'm going to show you some code. Right? So let me go ahead and close all of these. There we go. Go all the way back up here, collapse that. And let's take a look at a rectangle, a square, and a shape. Where's my shape? There we go. So a shape has an area, right? And maybe I can set the width of that area. Maybe I can set the height of that area or something like that. What about a rectangle and a square? Is a rectangle a square? Nope. But is a square a rectangle? Right? Are both of these shapes? Yes. So what's more? So if I go from shape down to something more specific, it's going to be a rectangle, right? And a rectangle has a width and a height. Well, you told me that a square was a rectangle, right? So I'll come down here and it extends rectangle again. So I've got shape, rectangle, square. Right? But what happens when I set it so that it's not a square semantically? I create a square that it's a 10 by 10, right? And then I immediately set its height. Did I change its width? No. So what kind of shape do I have now at this point on line 12? A 5 by 10. Even though it's a square, its type doesn't change, but its properties have changed it into a different type. And when I output area, what am I going to get here? 50, right? And it's still a square, though. Is a 5 by 10 shape a square? Nope. So this is the rectangle problem. Sometimes it's the circle, ellipse shape problem, but I don't know how to do the area of an ellipse. This is so much easier to present anyway, right? Areas, height times width, right? So I like to refer to it as the rectangle problem instead. Right? This is a violation of the Liskov substitution principle. This is something we'll come back around to when we look at the solid principles after we've had a chance to look at generic programming and polymorphism. Okay, so be careful here. What would be the solution here? Say what? I could change it so that let's see, a square. Anytime that I change its shape, let's see over here to a rectangle here. Set its width. Anytime I set its width, I also set its height. That seems like, well, you called width, not height, right? That's doing some behind-the-scenes magic for you to ensure that it's still a square. Is that really what you meant? Or is there a better way that I could have done this? Should I even allow them to set things, change things? Nope. What would have solved that issue? Making it into a final and final. Once you've created a shape with a width and a height, you can't change it at all, right? That problem goes away. What's another solution? Don't do this hierarchy, right? Yeah, I mean, conceptually, a square is a rectangle, and a rectangle is a shape. But why did you really need to do it like this? Right? Rethink your design if you're gonna do something like this, where that leads to sometimes this thing is a thing, other times it's not that thing. The is a relationship has to be a universal, right? For example, a linked list is always going to be a list. You can't take a list and make it into a set. That's a completely different concept. But sometimes collections are one thing and sometimes they're another thing. For example, do you see map in here at all? Nope. Because is a map a list? Is a list a map? That doesn't seem right. Is a map a set? Is a set a map? None of those seem right. So they didn't put it in here. It lives off by itself in its own hierarchy, right? And that's perfectly fine too. Right? Don't lock things into a hierarchy if it doesn't make sense universally. It always has to follow an is a relationship. Okay? So that's the rectangle problem. All right. We're almost at the end here, but any questions so far? No? All right, tomorrow you'll get a lot more practice in your lab by doing this. We give you what's called a UML diagram, something that kind of looks like this, but it also specifies all the methods that we expect. And it is a payroll system, I believe, that looks something kind of like this. But you'll have to design your hierarchy and design your classes so that it fits into that UML diagram. And you'll get some practice using interfaces, pure abstract classes, somewhere in between, right? And actual classes down here. All right, good luck.